Okay, so I'm all mixed up. Here, this one. Okay. So right here, yesterday we did this. Are you watching? Yesterday we took this one and we solved it first. So you get 2w and you get a 4. And then divide by 2, divide by 2. So w is less than 2, right? And then we made a number line. Let's make our number line. Make sure it's long enough. Okay, there we go. So when you went to put it on the number line, I would go to 2 and make a circle. What kind of circle would I make? Colored in or not?
An open circle.
Open, because it doesn't have an equals underneath there. The only time you color it in is if there's an equals under. So at 2, I make a circle, and I want the w's that are less than 2. Where would I find w's less than 2? Right or left?
Left.
Correct. Now, what that means is any value that I pick in this region, any value that I pick, if I plug it in up here, it will work, right? These are all the solutions that would work in this equation. How about this one? Let's solve it. Get all the w's together. And I get 2w less than or equal to 10. And I have w less than or equal to 5. Agree? If I go to put that one on the number line, I go to 5. Should I color it in or no?
Yes.
Color it in because it's got an equals. Color it in. And then I want the values that are less than 5. Which way, right or left?
Left.
To the left. So any value that I choose in the blue region solves the blue equation. Any value that I choose in this purple region solves this equation. So here's the new part today. We want values that will solve this and this one. I want values that will work in both equations. I can pick one and plug it in and it works here, and then I can take that same value and plug it in and it works here. Well, where would I find values that work in both? Where would I find values that work in both? Has to be both. It's where they overlap. So where do those values overlap? Or sorry, where do the lines overlap, I should say? Say it.
2 to less.
Yeah. Where do they both happen? From here this way. So basically today's, you're going to do 2 problems like yesterday. You're going to graph them above so you can see this one is an and. That means I want where they overlap. And your solution down here now, any value you pick from this region, if you plug it in, it'll work here and it'll work here. Does that make sense? Isn't that cool? Well, thank you for saying so, even though you probably don't think it really is cool. Cool? Anybody with questions on that one? Let's do another one, just for fun. Settle down, settle down. All right, so this one, I'm pretty sure we just did this one, but let's do it again just for fun. And I got divide by 2, divide by 2. I got W less than 2. Yeah. Oh, there's my other. Ugh. I got W less than 2. Oh, look at that number line. I got a lot of values on that one. Oh, going the wrong way. W less than 2. Where is that? Circle that 2 colored in? No, because there's no equals. And which way is less?
Left.
To the left, to the left. So any value I pick in this region will work right there. The other equation, let's solve it. Minus W. And I have 2W divided by 2. W greater than or equal to 5. Where is 5? Colored in or no?
Colored in.
Colored in because it's got the equals. So colored in. Which way are they greater than?
To the right.
To the right, to the right. Now, stop right there. If this one were an and, if I wanted to know this and this, where do they overlap?
Nowhere.
Nowhere. Remember, I want values that I can plug in here and it works, and use the same value and plug it in here and it'll work. But my graph shows there are none that overlap. There are none that work in both. So if this were an and, no solution. But it's an or. Look at what or says. One or the other or both. With an or, it doesn't have to be both. It could be both. If I tell you your choices are a chicken sandwich or pizza, you take one, chicken sandwich, or you take the pizza. Could you take both if you wanted? You'd have to pay extra, but you could. Could be both. But you only have to take one. So with an or, it's only where there's at least one of them. You only need to solve one equation. Well, so over here, don't these values solve one equation? Those values solve one equation. And don't these values solve one equation? So with an or, this would be your final answer then. All of these values work. All of these values work. Does that make sense? Yeah.
So does it matter what type of circle you put for the answers?
Yes, it does. Oh, right here I put no circle. It should be whatever is there. If it's colored in, colored it in. If it's open, then leave it open. Because this means 5 is included. You could choose 5 and it would work. If you choose 2 though, if I put 2 in here, 2 times 2 is 4, 4 take away 1 is 3. Is 3 less than 3? No. So 2 does not work. That's why you put an open circle. All the values up to 2 will work, but not 2. So whatever these circles are, that's what you put it as on your line. Does that make sense? Anybody with questions so far? Look at this. I've got my number line. Watch, I'm graphing my equation. I have this one. It starts here and it goes this way. And then I graph this one and it goes this way. Raise your hand if you know, if this were an OR and I graphed these two, where would I color in on my good line? If this were an OR and I had this graph and this graph, one or the other or both, where do you think I would color in, Addie? Where the top line starts, she says. What do you say?
In between the 2 dots.
In between here, he says. Well, here's what it has to be for an OR. One of them, it could be this one, or the other, or this one, or it could be both. I only have to have one, but it could be both. So if this is an OR, here's where I have one, the other, and right here is where I have both. So if it were an OR, you'd color in all of that stuff, because I have one of them in here and I have both of them down there. Does that make sense? Does that make sense? So I have a couple for you to do today. Like I said, if you don't finish, bring them back tomorrow. Or if you have questions, bring it back tomorrow. And after the STAR math test, we can work on it a little bit if you want, or if you need to. Do you have any questions on this? Do you have any questions? Anyone? Anyone? Yes.
So we have to put that line on the
So,
line.
yes, this right here will be your final answer. The graph where you put them actually onto the number line.
Okay.
So graph them up above to start with, and then put it on the actual number line for your answer. So I got page 480, 481. Did you say you had questions, anyone? I have 13 to 48.
What?
Yep. 13 to 48. Well, that's why I told you to bring it back.
Yeah.
JK. LOL.
Wow. That looks like a shoe.
Did I get you?
That looks like a shoe.
That looks like a shoe.
You just need the laces.
Just need the laces.
Ooh.
This is David on a good day, Wisconsin.
Well, sort of.
Studio.
Yeah, my daughter works there. My daughter produces Good Day Wisconsin. Excuse me? Hurry up. You know, Fox 11, the good one.
Yep, I like that one.
Oh, good. Oh, I thought I